Find the volume of a pyramid with height 24 and rectangular base with dimensions 6 and 10. So the height is 24 of this pyramid. It's 10 by 6. We're going to set up a definite integral to find that volume. Okay, well, how are we going to do it? Well, we're going to need to, we're going to take these, they said to use horizontal slices. So you see this horizontal slice here, and it has a thickness of dy. So we're gonna add up a bunch of slices. Let's find the volume of each slice. The volume of each slice, well, it's going to be length times width times thickness dy, because length times width is the area of the top. Do that a little bit better. Well, I cannot do that well. I'm just squeezing that in there, aren't I? Area of the top. So the area of the top is length times width, and then the thickness is dy. So that's the volume of each slice. And I want to add up those by big S from the bottom. We're at the bottom, we've got y equals 0 to the very top where y equals 24. So from y equals 0 on the bottom to y equals 24 on the top, volume of each slice, which is length times width times dy. And y is our variable. So we're going from y equals 0 to y equals 24. Now, question is, what's the length and what's the width? We've got to get those in terms of y. How do we do it? Well, we're going to do a couple of similar triangles. I think you can see it right here. So how's it work? Whenever we do the similar triangle, we're going to do um, height of the top, over base length is, again, height of the top over length. So what am I talking about? Well, um, again, the whole height is 24. We're letting y be the distance from the ground up. It says right there in blue. Y is the distance from the bottom up to the slice. So if that's the case, if 24 is the whole distance and y is the distance from the bottom up to the slice, then the top part is 24 minus y, isn't it? Again, if 24 is the whole thing and y is the bottom part, then the top part up here is 24 minus y. Well, that's what we need to use, because we're going to say 24 over 10. I'll start, here I'll start with the 6. So 24 over 6. So 24 over 6, which is the height of the top, which is over the 6. That has to equal the height of the top, which is 24 minus y, over the length. Do you see that? I know this is the part that's hard. Take a close look. This can be tricky. So we're saying the height of the top, 24, is to 6, like the height of the top here, 24 minus y, is to L. See how those are the same thing? This comes down to 6, like that comes down to L. And then likewise, then we're going to have to cross multiply. But first, let me set up the other one. Likewise, we'll do height of the top over width is height of the top over width. So again, I'll do the height that's above the base, which is 24, over 10, the width, is 24 minus y over w. Did you see how I came up with that? So again, I'm saying 24 is to 10, like 24 minus y is to w. All right, so I've got my two relationships in which I can solve for L and W. So I get 24L is 6 times 24 minus y divided by 24. Boom, and there we go. There's the L. Now let's do the W down here. Cross multiply. 24W is 10 times 24 minus Y divided by 24. And there's W. We got W, we've got L. So now we can plug them into our integral. We grab our integral and bring it on down. That's the integral from 0 to 24. So I'll bring it here. So that's the integral from 0 to 24 of length times width times dy. So the length first, 6 over 24 times 24 minus y. So that's the length times the width, which is right here, 10 over 24 times 24 minus y times dy, the thickness, right? dy. So there it is. There's the integral, and that's we're just going to stop right there. We're not going to actually crank it out. We could do that, but we're just going for the setup. So there we go. There's the definite integral that will find the area of that pyramid. And so again, the hardest part, it's just each slice is length times width, but how do you find that similar triangle? So again, 24 is the entire height is to 10, like 24 minus y is to w. And then the same thing on the length side. That's how we have to set that up. And so there we go.